Hi everyone. Hello. Welcome to another Primera Machine Learning seminar. Today we have Pedro Saleiro. He is the co-founder and chief AI officer at Opnova, and he's here to talk about computer use, the last frontier of LLM agents. Thank you for coming, and thank you, Pedro.
Thank you, Teresa and Gonzalo, for the invite. Can you hear me okay at the back of the room? Okay, thank you. I'll start with asking a question to the room, not to the Zoom audience. Have you ever used a computer use agent ever? Right. Are you developing research work on computer use? Okay. 2. All right. Great. I hope that next time I got an invite from Gonzalo and Teresa, there will be more research work in computer use, because I believe it's a very attractive area for PhD work at university level, with the commoditization of frontier models with open source, them becoming, let's say, almost infrastructure. There is plenty of opportunities and research problems to tackle one layer above the model itself, and one of those applications are in specifically computer use. And I'll start with a little bit of let me see if the command is working. It should be. Oh, sure.
On? Agora tá on? Não, se tá on.
All right. Easier to prompt LLM than getting this to work, but I'll try my best. I'm a little bit rusty on that. So where we are today, kind of divided the current type of agents that we see these days in these 3 types: coding agents, personal assistants, and autonomous agents. I argue that coding agents, especially what we have seen with Cloud Code since the Opus 4.6 release late in November, and we all have seen on LinkedIn and on X the true exponential growth in revenue of Anthropic, almost like a vertical line in the last few months. Coding agencies are becoming, I'd say, mainstream, especially in engineering, research domains. And in fact, I believe that vibe coding is just a transient concept that will no longer hold in the future. It will be just coding will be performed through these coding agents. Okay. Good. No? As I said, let me then. I'll share the entire screen then. All right, great. Then we also have seen the rise of personal assistants, although the not so popular Copilot Microsoft, that at the end of the day they are connecting Claude underneath. But personal assistants like people are increasingly using ChatGPT interfaces and Claude interfaces and Gemini interfaces as this kind of daily assistance. You can now have routines that you run on Cloud Cowork, that every day it will fetch your email, will prepare a draft response to your emails based on the prompts and the, let's say, the policies you define on those routines. They are mostly reading and creating content. Same for creating PowerPoint presentations. The email I just mentioned, they are suggesting, they are not taking decisions for us. And at the end of the day, we need to go to the draft folder of our email, and then we decide which ones, if we want to tune the content of the email we want to send. So typically, we are in the loop. We may not be on every single turn, but at least at the end, before committing the output, we are verifying the results of most of them, or what is possible. I'm pretty sure professor universities may have a different opinion on actually grading materials that, people read a short email, maybe a 10 pages, essay. It would be a different conversation. And then there is these autonomous agents, which is, to be fair, it's the holy grail in a way. That's what the advent and the promise of the AI agents in the area of generative AI is to actually have agents that are autonomous, they are proactive, they are reactive to the environment, they have different types of sensors. So in a way, it's materializing the definition of an intelligent agent from the Russell and Norvig modern artificial intelligence textbook, which is a seminal the definition of what an intelligent agent is. I think we haven't materialized that definition yet. We are close to that, but that's not the case. There has been the OpenClaw experiment. People are very excited about these autonomous agents, but I argue that for true back office operations in enterprise, these agents are not reliable nor prepared to be actually released into the wild. By coincidence, a couple of days ago, Benedict Evans, thought leader, I can now say, on macro trends on technology. Every 6 months, he releases a presentation. Last one was actually last Sunday. And in his presentation, basically, he assumes as table stakes that is inevitable that all the boring stuff that are popular across all the back office operations, all of our jobs are plagued with mundane tasks that we'd rather not have to go through them. Even professors have to do it, founders have to do it, PhD students have to do it. Everybody needs to go through this more. We can call it bureaucratic or mundane or repetitive type of work. And those operations are ripe for automation. And there is also, from economics perspective, this open question of there are certain industries in which there is greater incentives for bringing these automations to reality. And I'm going to talk about that next, where the economic value lives. So, in enterprise or in a large corporation, there are so many operations, roles that in a way are, a container for multiple tasks and workflows. We have at Opnova automated the workflows that we had people just every day looking at the screen, extracting a VAT number from an invoice, comparing that number with what is in SAP system, verifying the codes on the invoice if they match the policies and the rules. And these people are just doing that over and over every day. So in a way, their job is just a collection of those tasks to be done. And I mentioned finance example, but HR, compliance, legal, IT, and security are plagued with these mundane, repetitive, low interest tasks. And particularly in regulated industries, talking about finance, healthcare, government, transportation. There are so many legacy systems that lack API and connectors that one may think that, you know, in the future, everything is going to be built with agents. There will be APIs, there will be agent-to-agent protocols, and we are done. But I'm almost 20 years into my professional career, and this promise happened with SaaS advent and cloud advent. And in every job or every project I participated, there is still complex, non-interoperable ERP system of record. Worked at Feedzai. All the banks have these core banking systems. Analyzing fraud case involves getting information from multiple disconnected systems. And the reality is that the agents are very suitable to create a layer on top of these disconnected systems, then abstract them in terms of all these back office processing operations and workflows. And therefore, there is a tremendous, I'm not going, I thought about putting a number here, but I always feel a little bit odd on showing trillions of dollars of opportunities. I don't think that's, I'm not pitching here for VCs, but pitching on working these topics are definitely going to be relevant for the next 5 to 10 years. And they are far from being solved, contrary to coding agents. And I'm also going to talk about it. So what is a computer use agent? Today, computer use agent is becoming an umbrella for any intelligent digital agents, let's call it in a way. So there is an environment, and this environment can be the operating system. It can be mobile, can be Windows, can be Linux. And these agents are tasked with goals and definitions of a plan of work to be done, and they have access to an action space to computer interfaces, meaning they can decide to click, they can decide to scroll, they can decide to type information in a form. They can call APIs if needed. They can do backend transformations on databases. They are not restricted to only operating the interface. They are not, in this definition, they are not a tool that are available to agents to operate computer interfaces, because if you use, and if you are used to use Cloud Code, there is MCP Playwright for your browser, and Cloud Code can do something on your computer. I'm talking about these agents that are tasked, and they can be goal-oriented on defining what is a sequence of actions given a computer state that I need to perform to progress towards the goal that I've been tasked. And this creates this so-called agentic loop that on every action that is performed, there is a new computer state retrieved. Based on the new computer state, the system performs the next agent based on the model decoded prediction of what is the next best action. This is a canonical definition. I'm not so sure if the computer use is going to be the term in 2 years or 3 years, because it's such a broad concept that computer use seems a little bit very specific, defined to the scope of just controlling a computer and a keyboard. One aspect that is fundamental in computer use agents is the perception. So these agents mimic the way humans perform work when there are no APIs available, meaning that they are computer vision based, so they see the screen the same way a human does, and then that contributes to the concept of the current state of the computer. So there's kind of a paradox in a way that when you think about doing mundane back office operations and you think about Olympiad math or coding highly complex systems, we tend to say that the level of intelligence required on math and code is so much superior than doing mundane repetitive, that basically you have this episodic memory that you're basically repeating the same clicks over and over again. But in fact, and this is called a paradox that happened before, called Moravec's paradox, that it has to do with the perception in robots, that people have the expectations that perception is so natural to humans that it's going to be natural to the robot. The planning and the reasoning aspects of analyzing the state and planning and the memory are the challenges, not the perception. And we are like decades of work in perception to get better and better computer vision models. And there is this paradox in a way repeated in this kind of frontier application tasks for LLMs, in a way that, in fact, because we have verifiers, math and code, we run them through the compilers and or the proof, and basically we can use reinforcement learning and other techniques to improve these systems, while the computer use, in a way, each application, each workflow, it's their own micro world model that needs to be tackled. There is this concept of contextual understanding. When I'm deciding where to click next, I'm keeping context that 4 screens ago, there was a pop-up that I decided that changed something that has implications down in, we can call it the DAG of execution of doing work in a computer. And there is this aspect of tacit knowledge that I'm bringing the SAP as an example that, I don't know if you know SAP, but it's most widespread European technology product worldwide. It's present on every large enterprise for managing accounting and finance operations and supply chain. There is so many different use cases on SAP, but each SAP on each enterprise, it's completely different from the SAP on the other bank or in the telco or in the energy utility. So having a generalist model that knows how to operate SAP can for sure navigate menus and buttons and transactions, but doesn't know what is a custom workflow, what entails some specific codes, what entails the policy and the rules to verify a given workflow. And therefore, I'm tending to believe that a single model will not be able to capture all these knowledge, and this knowledge will have to be passed at inference time to the model when executing this type of workflows. So now talking a little bit of Opnova, so we don't stay in the vague abstract concept. So we at Opnova, we are building computer agents for enterprise operations in regulated industries. For many reasons, we decided this subset or vertical in a way, because in regulated industries, there are very specific requirements and there are very well-defined processes that need to be executed. When we look to research papers in this area, they are more open-ended type of tasks that book me a trip to San Francisco or find me the latest, trends in fashion. But in regulated industries and in back office operations, there are well-defined processes in which even an autonomous agent will not have the freedom to decide what is the best next task completely in an open and exploratory way. There will be definitely a set of defined policies, a set of defined tasks that define the job, and therefore it's more tractable today when we are waiting for the evolution of these models and the capability of these systems. It's a more tractable problem to tackle and to bring innovation to life. And there is a huge economic pressure and incentive to automate these mundane and repetitive tasks in these regulated industries. So our agents are purely vision-based. So as I mentioned, they look at the screenshot of the computer. All the tasks are in process are defined in natural language, including the policies. So this is something that in regulated industries cannot be an obscure model-based planning that nobody can see and verify and check. So the plan for the task is visible to the end users, can be auditable. What is the plan of workflow? Every time the workflow is run, although with dynamic inputs, because we are operating a specific invoice, or we are creating an account or resetting a password to a specific user. Although the inputs are dynamic, the definition of the task stays the same and can be well audited and approved. We can control what is the action surface. There is no way that in a related industry, a bank will allow to connect any MCP server that will expose tools and connectors to different applications. All of the tools available in the action space are defined and well scoped. In fact, we even go one step further, which is if the given step on the task won't require specific tools, we only allow the model to select the tools relevant for that step and not any possible tool available in a given moment. And every screenshot, every step, there is produced, let's put unquote, explanation of why the action performed was the one selected. What is the current state of progress of execution of the task? What is a screenshot of that current state? And we have all of that for every single step in the execution. And actually show here very quick demo of a use case in security operations on when creating a user account. And I'm going to create a user account for Mario Figueiredo on Fiserv. It's a core banking application that every bank in US has Fiserv signature as a base core banking application. We have seen this in different customers. It's an IBM IS400 green-like screen, native application. Here is, I'm showing an emulator, a mock emulator that we built with Cloud Code. So we got the screenshots and we can emulate the interaction. And we got a recording of the clicks and the time series of types, almost like a keylogger on the keyboard and the mouse. And basically, every step is going to produce a content explaining what is the action performed. There is an evidence of a screenshot. At every stage, the agent is operating the application as a human would operate. And basically, this integrates back to the ticketing systems or identity and governance application, allowing to automate these very manual. People have to be trained on operating these legacy types of applications, and they are not going anywhere because replacing core banking application. And we know that in government there are also some examples like that. No way that we are getting to the end here. So the user was already enrolled, and now just showing example of a screenshot for auditing. All of the trace of the agent is stored, and auditors and operators can inspect every single action performed. So how do we train computer use agents? At this moment, there is no end-to-end single model training of the computer use agents. There are some of these steps that are bundled together in training, but some of them actually happen at the inference time, like the continual learning and the memorization of the context. So it always starts with a visual language model, because we need to have a screenshot from the computer. And this visual language model, being high performant on generic visual understanding tasks, can then be fine-tuned in a grounding task. And I'm going to explain later what grounding means, but basically we are connecting, relating the concept of a natural language instruction or natural language concept with a region on the screen, thinking about the name of a button, thinking about scrolling, thinking about clicking, what that means for the model to understand and to relate, coordinate in an action on the computer with a natural language instruction. Then the third step is supervised fine-tuning on trajectories, because we need to account for edge cases and recoverability. Sometimes there is a misclick, grounding are not 100% effective, and I'm also going to cover that. The agents need to be able to recover and course correct to the expected path of execution, and therefore supervising fine-tuning on trajectories allow the model to bring that extra level of robustness to allow for knowing that given the task, given the context of where I am in the execution, given the current state and the previous state, what is the action? The action may be course correct. So accounting for all those different trajectories. Then there is also this early experience aspect of through prompting conditioning the action space to very well define set of a plan of a task. So in order for you to validate this user or fill this form, you have this information, and this information is going to match these specific parts of the form. And this can either be manually defined or can be through a planner in a hierarchical setting, another LLM that defines the plan for the executor that actually then decides what is the next action. This later can be tuned with reinforcement learning. And there is also the aspect of continual learning, which is when we release these models, the knowledge that is encoded through execution, is it just simply discarded? So every time I'm executing a transaction on SAP or on ServiceNow or in a core banking system, I'm going to start from the same clean state that in the previous execution. So when I'm accumulating executions, how am I codifying that episodic memory in a way that gives context to the agent, not only in terms of the process, but also in terms of navigating that maybe the plan was not correct for a given screen, needs to be course corrected for that screen because I needed to course correct the action through the execution. So it can be thought about critiquing the previous execution and condensing that critique on more instructions to be then used later. There is also this aspect of curriculum learning. So instead of grounding the agent on specific demonstrations, allowing the agents to explore an application, to learn how to navigate an application. Like you may have a budget, let's say 100 executions to explore how to navigate an SAP menu, and the agent will just be in exploration mode and will codify that knowledge in a markdown description of how to navigate what is on each screen that will later be retrieved when necessary to execute in that context. Also talking about something that we realize that in regulated industries, when we go to the third-party risk management, is typically the toughest part these days when working with banks. Is not because there are no use cases, it's not because there is no relevant business case, it's not because people don't believe that technology works, it's the third-party risk management. Banks need to apply for regulations, and data and privacy are critical. And when we are orchestrating core back office systems, there are going to be not only PAI data, but also business data that are being captured on screenshots and are being, in a way, sent in the context window to inference on LLMs. And these LLMs can be just a public endpoint, thinking about Anthropic API, but in banking, typically bring your own cloud deployment is preferred, which means that banks have their own cloud accounts on GCP Vertex, on AWS Bedrock, or Azure AI Foundry, and we are using that endpoint model. But even then, there is this concept of zero data orientation. The data cannot be stored on the server side, but there is control abuse. So lots of things that you only learn when you are doing a startup, and you actually need to not just showing a demo, but implementing in the field. And basically, this having our own proprietary model that comprises the part of grounding in SFT trajectories tuning together is basically what we are doing with this model. The inference timing aspects of the learning can be used on demand on the deployment, but we were accepted at the NVIDIA Innovation Lab, which allow us to have access for 3 months for 8 times H100 cluster that allow us to fine tune our models in our simulated trajectories, the same way I showed the demo with Mario Figueiredo. We are doing that for every application or every back office work we do with these simulated environments. And this way, basically, we were able to get 10.4% relative gain compared to the base open source model that we fine-tuned. If you're interested in knowing which model, I'm happy after the talk to offline to talk about that. So let me just check time. Teresa, I don't know what time we started. 10 minutes. All right. So, okay. So just talking some aspects about grounding. So grounding is a compounding problem. So you may have a good plan on how to execute a task, but if you miss a click, then the whole task will fail. And when we are using Cowork, and Cowork was not able to insert a given value on a spreadsheet, we go there and we fix. In autonomous operation, in these regulated industries, in which, in our case, we have dedicated virtual machines for each worker agent, so that the workstation is operated by our computer use agents. They are doing the back office work. Just misclicking and missing a step in the execution will result in just a zero success on the task execution. And thinking about how that compounds, and I'm going to talk about also evaluation, but if you have a probability of getting 95% correct coordinates on what is the next action to be done, and if you have 30 steps, then basically to the power of the 30 executions, you get the 21% success rate probability, which also show us that actually in early days, we were doing evaluation on an action-based benchmark, but it's on the task level that is where you see if the work can be done or not. So I also wanted to show this one. It's already from 24, but for people that are not familiar with what grounding is, it's a very relevant demonstration here on the screen. So basically, is a set of tasks containing all the possible tasks you can have on the perception of what is on the screen. So basically, it can be spatial reasoning. It can be what is relative position to a given anchor. So what is the element below the title? What is the element above the menu? You have examples of these questions like select the most suitable website that matches the new page, and you have to define what is the icon there for Instagram. Find the bounding box coordinates of the elements you need to click on to perform this action. Learn more about perfect throws, and then there is the coordinates. So this is a set of tasks, low-level tasks, that we have to train the model to get from a VLM to a model that can have this spatial reasoning of deciding where to click where on the interface. On trajectories, and I'm going to talk also about work we developed. There is this, basically, this is, when you're hearing to podcasts, there was this saying that the pre-training step is exhausted. There is all the data that is possible to pre-train an LLM is on the web, but there is a gigantic set of data that sits behind firewalls on large organizations, all the process data, all the databases in system of records that are not publicly available to frontier labs to fine-tune those models. So, in fact, there is one open resource that still remains, which is YouTube. YouTube is full of demos of using applications. Every application, every product there is out there, there is a YouTube video of someone giving a tutorial on how to do that. And in fact, there are some rumors that Anthropic computer use was train on YouTube videos. That was some discussions, that's because there are terms from YouTube and Google, but you know, at the end of the day, they are all friends. This is also a part of recent research on how can I get trajectories to fine tune on these computer use execution. So these are two relevant examples of defining that. One thing that YouTube videos don't have, and actually at Opnova we have, is there is no keyboard or clicks data. So it's all, the state transition needs to be inferred visually from frame to frame. This is actually what are the core contributions of these recent works. In our case, what we are doing is we are recording an operator doing the work with our own agent application installed on their virtual machine, and the work is because I get the stream and I can align the frames with the actions on the computer, and that allow me to extract ground truth. And this is actually our first patent that was allowed by the USPTO, is exactly that a loop of based on a task recording with a set of frames and the metadata from the keyboard and the click. We generate a plan for the task. That plan goes through our action predictor. We don't actually need to execute that. We just need to get the prediction and compare it against what was extracted as ground truth from the video. So in a way, it's almost like completely overfitting what was demonstrated in the video to the sequence trajectory of the agent. Then we get the execution and basically the ground truth at these different steps and expected actions on each one. And if there is a miss, there is a critique meta prompting one that will critique the miss and will feedback to the plan generator to then correct until the full execution matches the ground truth from the video. In this way, we went from early days 2024, we doing the prompts for the tasks, having a Zoom recording, translating the Zoom recording, and we trying to generate the prompts, to having an operator from the customer recording a video, and the video gets auto-tuned to the plan for executing the specific task. So in terms of planning, and because of training LLMs on the web, they know, and there is a universal concept of what a UI looks like. So everybody knows that there is a menu on the left side or nav bar. There is a kebab menu to extend to get a menu on mobile. So being it in Portugal, other country, other continent, there is this universal concept of what usable UI looks like, and LLMs basically, especially the ones with multimodal capabilities, were trained in on web corpora that allow them to do that. So what these world models do is, when they predict the next action, there is a model that tries to predict what will be the next state after the if you click on something. And this way, it can basically do a typical research, trying different actions, assessing which one gets the best outcome, and the outcome is predicted, and then selecting the best action to perform. Then, as in other Senai Clear 2026 paper, as in other tasks, sometimes a very well curated data set entails better results than just more automated training data collection approach. Here is just for you to get access to under the hood what is architecture of an open source agent. I'm not going to reveal Opnova ones, but you can see that there are some typical components of verification, search, having a grounder that is just knowing a specific instruction without context, what is going to be the click, that can be decomposed in different architectures. So lots of research problems and research tasks for PhD students to perform work. So that's also interesting, this composability of these architectures. And easy to do ablation studies on what makes more impact or not in the end result. About memory, and I was commenting with Mari that my PhD was mostly information retrieval, and these days all these concepts are resurfacing as very relevant these days for having these information extraction and knowledge synthesis and creating knowledge graphs from executions and from not just from chat history, but also from the agent execution. So also a hot topic at research at this moment. And talking about another innovation we have developed at Opnova. And do I have 5 minutes? I think I'm almost finishing. Okay, so in early days when we got the first design partners, we have two of our VCs are Japanese funds in US, and typically with VCs they get you the first design partners from their network. That's also why you want early stage VC. And there was this use case of doing this back office operation in a very legacy Windows native ERP that was basically a Java applet. And when we were trying to do, I was basically learning myself to do the task, to do the work. So we went to Japan and we learned how to do it. And after a couple of weeks, I already knew it without even understanding what was on the screen. But the process was the same, the input data was different. Now I'm doing that, and I started to realize that I was only looking to specific anchors on the screen to let me know where I am in terms of all the different pages and menus on this ERP. So that suffering midnight and sleepless nights just kind of made us to have this obvious but game-changing realization for us as an early stage startup that if I know where I am in my execution graph, and if I know which anchor elements on the screen are visible, and I don't see the dynamic information, the user data, the specific order form, I can get from a cache data very high. We created this concept of basically we are masking the dynamic parts of the screen and only using these anchors. So basically what you're doing is this hierarchical caching mechanism, which in the graph, I know where I am in execution because I can pass through the same screen many times in doing workflow. So I can have the main menu, I go do something, I go back to the main menu. Just because it's the same main menu doesn't mean that is the next action is the same, but with the graph and creating that execution graph, I know where I am. And then there's another aspect, which is because we were by design getting all these explanations, justifications of the actions, we started to see patterns on certain actions. The model already tells me which parts of the screen are more relevant. So I can train an auto masking system that will draw these black masks for us. And in a way, what this entailed in practice was that we are getting deterministic execution when needed and adaptability when we need to verify if the data is correctly inputted, confirm certain computer state transitions, but all the rest just gets from the database, no inference, and we got on average 85% token reduction cost on executing these workflows, and talking about tens of thousands of executions as we have in a customer that is processing 50,000 invoices on SAP per year. This makes all the difference from a reliability perspective and from a cost perspective as well. And in a way, it can be thought as almost like, now it's my sales person in me not resisting, almost like a physical guardrail, because if there is a pop-up that was not expected, then the AI will be used seamlessly because there is no match with the mask screen. But at the same time, if there is slightly variation of outputs on coordinates, and sometimes if the plan is underspecified or there is low resolution on the screen, I may click a little bit on the right side and the whole workflow will fail. If I have a good execution, I memorize it, and then the coordinates will always be the same, and I'm robust to this variation of the coordinates. And just, I'm going very quickly here. No, so basically, something that people are realizing on the benchmarks is that what people actually value is the process, always following the same process and how you get to the results, not going to shortcuts. And that happens in the regulated industry. So it's something that you can go to the most famous computer use benchmark, which is called OS World, and you are getting already 80% success rates. But that doesn't hold in practice when we actually need to verify the steps. Talking about risks, and when becoming a founder, I just leave the risks. Before I used to start with the risks. Now I just leave the risks for the last 5 minutes, but they are still there. So there's something there. So basically, it's kind of being very simplistic, almost like a Pandora box of the risks, but with the right security deployment. So we are always using least privileged approaches. Our agents, if they don't need access to the internet to perform the work, the customers should not give access to internet to the agent. We are always constraining the action space based on the context. So no tools that are never seen are there. We are critiquing the runs to understand points of failures. But in fact, this is still automating tasks. We are not yet automating jobs, but we want to automate the job. So having true autonomous agents that have the freedom to decide what is the task that should be composable, what is the best next action to be done, what access are necessary, we are still far for having that reliability, and the risks are definitely very large. And just to summarizing some of the iClear 2026 tests, some obvious ones is people just putting instructions on images, instruction online, people posting on Reddit malicious things to be done, and the agent, when doing exploratory to get knowledge, reads from a Reddit post and then tries to execute that. But one that I think is even more interesting is this, or challenging, is the auto illicit one. Actually, paper with some very preeminent researchers, which is if the task is underspecified and there is typical behavior on going through shortcuts, there is a risk that, for instance, you ask to create a restricted SSH user, and there was no password authentication. It was MFA, for instance. But the agent, because it's an admin account, decided, oh, for me to do that, the shortest path is to enable password authentication. We don't need multi-factor, just password. And just because of that, the whole security of the system gets, in a way, compromised with the agent doing that work. So very different, interesting research topic here. And here I just want to show that what we need in practice is not pass at K, but what I showed, we need to have consistent, successful executions over enough large sample of executions. We typically, as a rule of thumb, we use 20. So it only goes to production after 20 successful executions. But because we are a startup, if in a research paper, I'll recommend at least 100. But something that we want the best of both worlds, reliability, but the adaptability when an exception occurs, an edge case occurs, and ending again with benefit events in a kind of a provocation. So this one is, in a way, something that happened in the past. There was this job of elevator attendants, and all the job was just a task. And this is what happens to the demand and actually the job over the years. But more often, what happens is that the job changes when we automate a task of the job. And that's exactly what we are seeing in practice. We have in our banks, we have deployments. We are automating tasks that were done by 7 full-time employees, but they are still on the job doing different tasks, not the mundane ones that they had to do every month. And just to end with, actually, dinner is one of my favorite futurists are thinking about the implications and of what we are building with AI. And I really think this one is very relevant for the case. So if we use to achieve our purpose a mechanical agency with whose operation we cannot efficiently interfere once we have started, open call moment, because the action is so fast and revocable that we have not the data to intervene before the action is complete, then we had better be quite sure that the purpose put into the machine is the purpose which we really desire and not a merely colorful imitation of it. So it's our daily job on under-specifying prompts. So that's my final note here. Thank you.
Oh, okay. I have a microphone.
Hi, thank you for the talk. One feature of does it even work? Oh, sure. Sorry then. So one feature of UIs that we know all about is that they tend to change. There are updates in applications and in interfaces. And is this something you take into account right now? How models can adapt to those changes?
Absolutely. So actually, we designed the product to account for that, and it's one of the first questions our customers ask is about, because they are, let's call burned by the RPA promise of RPA will automate everything, but in fact, you change the selector, you change something, it's just brittle. But with vision and having this grounding of semantic intent linked to a coordinate and an action on the screen, we can adapt. And actually, it already happens to us in our deployments that there was an upgrade of an application, the UI changed, and actually the AI on an explanation flags that, but decides to click on the right place. If there is more dramatic changes, we typically just record a new demonstration. But definitely something that with this technology, you can definitely be robust to these changes in UI.
Sounds great. Thank you.
Hello, thank you for the presentation. My question is kind of similar to the Dominica's question as well. You kind of started the presentation by talking about like that we might be on the cusp of like solving quote unquote coding agents. So my question is kind of, couldn't we do something very similar, but instead of training a model, like just having a coding agent actually code the necessary like RPA scripts to do the tasks? Like where's the trade-off between just coding up the actual like trajectory, or I don't know what to call it, like the actual RPA automation script versus training a model for like the trajectory that we want to do, etc.
That's a relevant question on the realm of possibilities, but in practice, what we see is like if you have a compiler to execute the code, you verify the results much more efficient way. Instead of just having to execute the code, replay the execution, critique the execution. So the aspect of latencies in producing a program is something that it's still to be tested in practice. You can argue that you can produce the code once and reuse it forever, but then you also need to have a monitoring in place to see when it fails. So I see that more like a subcomponent in the larger arc of components that a true computer use agent requires.
Okay, thank you.
Hi, thanks for the talk. My question is more on the training of the model. You talk about word models, and I think even it was yesterday that was a paper release that normally people do RL, but on the actions, and they never train with the observations. When you train your model is only conditioned on actions or also trained on observations. So I perform this action, and I will expect to see this screen, or it is just like observation and produce this action.
You can train in both. Actually,
okay.
The question of having the data and having the also agent judge
Yeah.
to evaluating if the new observation is expected or not expected.
Thanks.
You mentioned about the risks and also the accuracy or confidence on the task itself. Do you have any way of measuring that?
So typically, successful executions over a large number of trials. That's the most effective for the job that we are doing. In research papers, you have different levels of evaluation. You have at action level, which is more on the grounding, on the planning, but also on having these pass subscript to K, which is basically go through this trial. So typically, that's the basic. It's usually very binary. Either it failed or didn't fail the given step action that should be done. There are no more complex metrics. And in fact, as I mentioned, it's very binary. It either works or not, and it should be reliably work over many trials.
Even for the risks as well.
What do you mean for evaluating the
risks?
So the probability. Okay, sorry. No, it's the ACR, the attack success rate. That's the typical thing that this type of red teaming security papers have. In ICLR 26, you have red team, QA, and others, and agent illicit is just to see if they're able to get the agent to perform an high risk action. That's the attack success rate.
Okay, thank you for the talk and congratulations. In new iterations, do you see a bigger improvement on refining the models or the harness? And with the new models coming out, do you see a change in that trend?
Okay, so the major breakthrough was from Sonnet 4 to Sonnet 4.5. That's what in these grounding capabilities, so talking about computer use agents. Since 4.5, I'm not seeing much improvement in practice about grounding itself. It's about the harness and about the complexity of what we are trying to build. There is also the question of explosion on tools. So we are very strict and rigid, not allowing to get many tools possibilities at each moment, which also reduce the degree of error. But in research work, there is definitely lots of interesting aspects to test in all of these components, from the reinforcement learning, from the grounding itself, thinking about there are so many different worlds of tasks to be done that easy for a PhD student to just simulate just that task. So I'm getting a specialized agent on grocery shopping, and just for grocery shopping, all the different levels of intent, the preferences, the policies. When you go with a dedicated brand or you go with another brand because of pricing. So all of it, I'm talking a very mundane example of a task that I think for me, for instance, I'd love to have my agent doing my grocery shopping for me. But there is definitely many different tasks in healthcare, in government, that you can just simulate the traces for those tasks.
Hello, thanks for the lovely talk. I'm August Stivre. I'm from the Department of Computer Science. So I work with interfaces, so I'm here more as a sort of trying to see what's going to happen in the near future regarding these sort of agents that can sort of undermine a lot of the work that we sort of do in this space. So I guess I just want to pick your brain. So for example, if I would want my robot to sort of write me an email, sort of send an email on my behalf, like the robot would just sort of execute sort of my verbal instruction and sort of send that email. It wouldn't actually, I wouldn't have to program a robot to type keys. So keys are an interface for humans. A lot of the interfaces you've shown, or all of them, are for humans, right? So it seems like a lot of this work seems to be sort of a stopgap in age that we are, in which we have these sort of legacy UIs or just normal UIs, and we're trying to get computers to execute our tasks through an interface that was built for humans. And if you actually achieve this goal of sort of killing all these sort of boring tasks, we actually don't need those UIs for humans, right? So humans don't need to have an UI that allows them to do those clicks for the boring tasks. So there won't be an UI, and the agents can just sort of execute tasks in a way that computers normally talk. So I'm just wondering, sort of, yeah, I guess pick your brain around sort of this. How big you think is this gap between actually going away with a lot of these UIs that we don't need for the boring task we don't want to do?
Thank you for the lovely question as well. At lunchtime, we were saying like the humans are very, very bad at forecasting the future. So I'm not going to forecast if the human interfaces are going just away, and if that will take 5, 10, 20, 30 years. What we are seeing in practice is that there is and this is not a justification, it's just actually a side effect that we are seeing, almost like a second order effect, which is, in a way, in the regulated industries, the customers tend to trust more the evidence collection. There is something that they understand. So they are used to a human interface and having all these screenshots of all the steps that if they need to do the job, if they need to intervene, they know how to intervene. Just creates, I would say, a very relevant aspect on either keeping both modalities, an agent interface and a human interface, because the humans may need to interact with the system. So I think it's very early to assume that we will not need to interact with an interface, or going the more extreme route in which humans will stop using mouse and using a computer. But even in that moment, the grounding is just a tool inside of all these harness and system of what are the risks, what should be the plans, what should be next actions. But ending with kind of my prediction, APIs were supposed to hit the world, they didn't. So I think the agents will not eat the GUI. But that's my, and in 10 years, we can definitely discuss it.
I'll be here.
Yeah. I hope I can also be here.
Question?
Thank you for the presentation. I was wondering in which stage the startup is, what are major clients, and in which phase of the pipeline. So you mentioned VLM pre-training, SFT, RL, continual learning. In which stage is the major bottleneck or the main challenges? What are the key future steps? Thank you.
Thank you for the question. So on the startup, we are 2 years old in April. We are a pre-seed startup. We raised $5 million US from early stage VCs. We are operating in Portugal, US, and Japan. 80% of our customers are banks. In Portugal, we have CGD, for instance. And the bottleneck we are seeing is actually on the people side. So aligning expectations of the operators, the change management of having operators reviewing, intervening on agents' work, creating the new human AI process, and aligning that expectations from the human side. For me, I'd say most of the problems I need to solve on a daily basis, and I have many problems to solve, are people issues and not technology issues.
Any more questions?
So I just wanted to ask, basically, like the main bottlenecks that I see to use the computer use and multi-agentic systems is like the grounding and obviously the security. So I wanted to ask, do you guys have like a red team team, basically what's like the possible surface attacks that you guys detected, basically. So, and how you solved it.
Sorry. So, very straightforward answer. I wish we had a red team. And I hope after the next round, we'll be able to have just privacy and security people just focusing on all those risks, because for sure, we are getting exposed to so many different use cases and surface areas for risk. But what we typically do is, because we are SOC 2 compliant, we have penetration testing, and we have consistently increased the prompt injection robustness to that on our platform, which is the major surface area that we have. Is imagine, like, because we receive inputs like usernames, passing a script on the username or asking it to do something on the PowerShell. So we have been consistently improving that, but we have a very self-contained deployment with very specific security restrictions. But I hope when we move to more autonomous agents that we have dedicated red teams to do the research on it.
How the errors that the agent takes, like you mentioned, like the compounding errors that into the building.
So, and I can share these numbers. So right now in production, we have 4% error rate on tasks, 4%. So that's the bar. Otherwise, below 90, nobody wants to use your agent in practice. Right now, we have 4% error rate on, and that includes not only the AI errors, but system errors, like some virtual machine connectivity is down, and the process. So includes all of those errors. But this important aspect, we are fine-tuning to the task, and that is a critical design aspect that makes all the difference to get this reliability with this reflexive memory, with all these innovations learning from the video. So that's what's making the difference at the moment. Oh yeah, and in the future, all of that having the concept of the job. It's not only the task, because maybe in accounting I have a validation of invoices, but then an accounting of invoices. So the same invoice in a bank goes to different tasks for different people is throughout the life cycle of an invoice until someone approves it to be paid. So that is definitely episodic memories that need to be not synthesized in order for us to, in the future, have the true job automation for the task. I think we have for a long time is the last one. Oh, absolutely. Sure. So think about on the graph of executing a task in the computer, think about creating a user. There are typically on average 85% of steps are more robotic on typing information, clicking, navigating menus. 15% are more reasoning. So deciding if I need to follow a policy, if that's the moment to validate against a policy or a rule, a business rule, confirming that the data set on the screen is correct based on the inputs to confirm and move to the next step. So the 85% we can cache with this technology. Only the 15% need inference. It could be something like, for you, before you click a submit in a pop-up, you have to perform 50 actions. So you just need to verify at the end, or in some breaking points where you do the verifications of the data, because sometimes the data may be out of the screen. So only in that moment you need to have through inference to multimodal LLM to confirm if what's on the screen is correct. All the rest can be inferred with this approach. There are other types of tools or type of dynamic content that cannot be used with this. Something like defining what is the replace function or regex to replace something on a table. You need to assess the table, so we also need to verify the content before deciding. So those are also ones that are not cacheable at the moment, but the ClickOps stuff all can be cacheable, and we are seeing this 85% reduction in tokens. Okay, I think we are done.
Thank you so much. Thank you, Pedro.